What are the differences between a HashMap and a Hashtable in Java? Which is more efficient for non-threaded applications? There are several differences between HashMap and Hashtable. In Java, Hashtable is synchronized, whereas HashMap is not. This makes HashMap better for non-threaded applications, as unsynchronized objects typically perform better than synchronized ones. Hashtable does not allow null keys or values. HashMap allows one null key and any number of null values. One of HashMap's subclasses is linked HashMap. So in the event that you'd want predictable iteration order, which is insertion order by default, you could easily swap out the HashMap for a linked HashMap. This wouldn't be as easy if you were using Hashtable. Since synchronization is not an issue for you, I'd recommend HashMap. If synchronization becomes an issue, you may also look at concurrent HashMap. Note that a lot of the answers state that Hashtable is synchronized. In practice, this buys you very little. The synchronization is on the accessor/mutator methods will stop two threads adding or removing from the map concurrently. But in the real world, you will often need additional synchronization. A very common idiom is to check then put, i.e., look for an entry in the map and add it if it does not already exist. This is not in any way an atomic operation whether you use Hashtable or HashMap. An equivalently synchronized HashMap can be obtained but to correctly implement this logic you need additional synchronization of the form. Even iterating over a Hashtable's entries or a HashMap obtained by collections. Synchronized map is not thread safe unless you also guard the map against being modified through additional synchronization. Implementations of the concurrent map interface, for example, concurrent HashMap, solve some of this by including thread safe check then act semantics, such as Hashtable is considered legacy code. There's nothing about Hashtable that can't be done using HashMap or derivations of HashMap. So for new code, I don't see any justification for going back to Hashtable. This question is often asked in interviews to check whether the candidate understands the correct usage of collection classes and is aware of alternative solutions available. The HashMap class is roughly equivalent to Hashtable, except that it is non-synchronized and permits nulls. HashMap allows null values as key and value, whereas Hashtable doesn't allow nulls. HashMap does not guarantee that the order of the map will remain constant over time. HashMap is non-synchronized, whereas Hashtable is synchronized. Iterator in the HashMap is fail-safe while the enumerator for the Hashtable is not, and throw concurrent modification exception if any other thread modifies the map structurally by adding or removing any element except iterator's own remove method. But this is not a guaranteed behavior and will be done by JVM on best effort. Note on some important terms. Synchronized means only one thread can modify a Hashtable at one point in time. Basically, it means that any thread before performing an update on a Hashtable will have to acquire a lock on the object while others will wait for the lock to be released. Failsafe is relevant within the context of iterators. If an iterator has been created on a collection object and some other thread tries to modify the collection object structurally, a concurrent modification exception will be thrown. It is possible for other threads though to invoke the set method since it doesn't modify the collection structurally. However, if prior to calling set, the collection has been modified structurally, illegal argument exception will be thrown. Structurally modification means deleting or inserting element which could effectively change the structure of the map. HashMap can be synchronized by map m equals collections. Synchronize HashMap. Map provides collection views instead of direct support for iteration via enumeration objects. Collection views greatly enhance the expressiveness of the interface. As discussed later in this section, map allows you to iterate over keys, values, or key-value pairs. Hashtable does not provide the third option. Map provides a safe way to remove entries in the midst of iteration. Hashtable did not. Finally, Map fixes a minor deficiency in the Hashtable interface. Hashtable has a method called contains, which returns true if the hashtable contains a given value. Given its name, you'd expect this method to return true if the hashtable contained a given key because the key is the primary access mechanism for a hashtable. The map interface eliminates this source of confusion by renaming the method contains value. Also, this improves the interface's consistency. Contains value parallels contains key. The map interface. HashMap. An implementation of the map interface that uses hash codes to index an array. Hashtable. Hi. 1998 called. They want their collections API back. Seriously though. You're better off staying away from Hashtable altogether. For single-threaded apps, you don't need the extra overhead of synchronization. For highly concurrent apps, the paranoid synchronization might lead to starvation, deadlocks, or unnecessary garbage collection pauses. Like Tim Howland pointed out, you might use concurrent HashMap instead. Keep in mind that Hashtable was legacy class before Java Collections Framework JCF was introduced and was later retrofitted to implement the map interface. So was Vector and Stack. Therefore, always stay away from them in new code since they're always better alternative in the JCF. As others had pointed out, here is the Java collection cheat sheet that you will find useful. Notice the gray block contains the legacy class Hashtable, Vector, and Stack. There is many good answer already posted. I'm adding few new points and summarizing it. HashMap and Hashtable both are used to store data in key and value form. Both are using hashing technique to store unique keys. But there are many differences between HashMap and Hashtable classes that are given below. HashMap. HashMap is non-synchronized. It is not thread safe and can't be shared between many threads without proper synchronization code. HashMap allows one null key and multiple null values. HashMap is a new class introduced in JDK 1.2. HashMap is fast. We can make the HashMap as synchronized by calling this code. map_m equals collections.synchronized map HashMap. HashMap is traversed by iterator. Iterator in HashMap is fail-fast. HashMap inherits abstract map class. Hashtable. Hashtable is synchronized. It is thread-safe and can be shared with many threads. Hashtable doesn't allow any null key or value. Hashtable is a legacy class. Hashtable is slow. Hashtable is internally synchronized and can't be unsynchronized. Hashtable is traversed by enumerator and iterator. Enumerator in Hashtable is not fail-fast. Hashtable inherits dictionary class. Further reading. What is difference between HashMap and Hashtable in Java? In addition to what is said, HashMap allows null values, whereas the Hashtable does not. Also note that Hashtable extends the dictionary class, which as the Java docs state, is obsolete and has been replaced by the map interface. Take a look at this chart. It provides comparisons between different data structures along with HashMap and Hashtable. The comparison is precise, clear and easy to understand. Java collection matrix. Hashtable is similar to the HashMap and has a similar interface. It is recommended that you use HashMap, unless you require support for legacy applications or you need synchronization, as the Hashtable's methods are synchronized. So in your case, as you are not multi-threading, HashMaps are your best bet. Another key difference between Hashtable and HashMap is that iterator in the HashMap is fail-fast while the enumerator for the Hashtable is not, and throw concurrent modification exception if any other thread modifies the map structurally by adding or removing any element except iterator's own remove method. But this is not a guaranteed behavior and will be done by JVM on best effort. My source: http://javarevisited.blogspot.com/2010/difference-between-hashmap-and.html. Beside all the other important aspects already mentioned here, Collections API e.g. Map interface is being modified all the time to conform to the latest and greatest additions to Java spec. For example, compare Java 5 map iterating versus the old Hashtable approach. In Java 1.8 we are also promised to be able to construct and access hash maps like in good old scripting languages. Update? No. They won't land in 1.8. Are Project Coins collection enhancements going to be in JDK8? Hashtable is synchronized, whereas HashMap isn't. That makes Hashtable slower than HashMap. For single-thread applications, use HashMap since they are otherwise the same in terms of functionality. Hashtable is synchronized. If you are using it in a single thread you can use HashMap, which is an unsynchronized version. Unsynchronized objects are often a little more performant. By the way, if multiple threads access a hash map concurrently, and at least one of the threads modifies the map structurally, it must be synchronized externally. One can wrap an unsynchronized map in a synchronized one using map_m equals collections.synchronized map new hash map. Hashtable can only contain non-null object as a key or as a value. HashMap can contain one null key and null values. The iterators returned by map are fail-fast. If the map is structurally modified at any time after the iterator is created, in any way except through the iterator's own remove method, the iterator will throw a concurrent modification exception. Thus, in the face of concurrent modification, the iterator fails quickly and cleanly, rather than risking arbitrary, non-deterministic behavior at an undetermined time in the future. Whereas the enumerations returned by Hashtable's keys and elements methods are not fail-fast. Hashtable and HashMap are member of the Java Collections framework since Java 2 Platform v1.2. Hashtable was retrofitted to implement the map interface. Hashtable is considered legacy code. The documentation advised to use concurrent HashMap in place of Hashtable if a thread-safe highly concurrent implementation is desired. HashMap doesn't guarantee the order in which elements are returned. For Hashtable I guess it's the same, but I'm not entirely sure. I don't find resources that clearly state that. HashMap and Hashtable have significant algorithmic differences as well. No one has mentioned this before, so that's why I am bringing it up. HashMap will construct a hash table with power of 2 size. Increase it dynamically such that you have at most about 8 elements collisions in any bucket and will stir the elements very well for general element types. However, the hash table implementation provides better and finer control over the hashing if you know what you are doing. Namely, you can fix the table size using e.g. the closest prime number to your value's domain size, and this will result in better performance than HashMap, i.e. less collisions for some cases. Separate from the obvious differences discussed extensively in this question, I see the hash table as a manual drive car where you have better control over the hashing, and the HashMap as the automatic drive counterpart that will generally perform well. Based on the info here, I'd recommend going with HashMap. I think the biggest advantage is that Java will prevent you from modifying it while you are iterating over it, unless you do it through the iterator. A collection, sometimes called a container, is simply an object that groups multiple elements into a single unit. Collections are used to store, retrieve, manipulate, and communicate aggregate data. A collections framework W is a unified architecture for representing and manipulating collections. The HashMap JDK 1.2 and Hashtable JDK 1.0. Both are used to represent a group of objects that are represented in pair. Each pair is called entry object. The collection of entries is referred by the object of HashMap and Hashtable. Keys in a collection must be unique or distinctive. as they are used to retrieve a mapped value a particular key. Values in a collection can be duplicated. Superclass, Legacy, and Collection Framework member. Hashtable is a legacy class introduced in JDK 1.0, which is a subclass of dictionary class. From JDK 1.2, Hashtable is re-engineered to implement the map interface to make a member of Collection Framework. HashMap is a member of Java Collection Framework right from the beginning of its introduction in JDK 1.2. HashMap is the subclass of the abstract map class. Initial capacity and load factor. The capacity is the number of buckets in the hash table, and the initial capacity is simply the capacity at the time the hash table is created. Note that the hash table is open. In the case of a hash collision, a single bucket stores multiple entries, which must be searched sequentially. The load factor is a measure of how full the hash table is allowed to get before its capacity is automatically increased. HashMap constructs an empty hash table with the default initial capacity 16 and the default load factor 0.75. Whereas Hashtable constructs empty hash table with a default initial capacity 11 and load factor/fill ratio 0.75. Structural modification in case of hash collision. HashMap. Hashtable. In case of hash collisions, they store the map entries in linked lists. From Java 8 for HashMap, if hash bucket grows beyond a certain threshold, that bucket will switch from linked list of entries to a balanced tree, which improve worst case performance from on to all again, while converting the list to binary tree. Hash code is used as a branching variable. If there are two different hash codes in the same bucket, one is considered bigger and goes to the right of the tree and other one to the left. But when both the hash codes are equal, HashMap assumes that the keys are comparable, and compares the key to determine the direction so that some order can be maintained. It is a good practice to make the keys of HashMap comparable. On adding entries, if bucket size reaches treeify_threshold equals 8, convert linked list of entries to a balanced tree. On removing entries less than treeify_threshold and at most untreeify_threshold equals 6, will reconvert balanced tree to linked list of entries. Java 8 SRC. Stack post. Collection view iteration, fail fast, and fail safe. Iterator is a fail fast in nature. It throws concurrent modification exception if a collection is modified while iterating other than its own remove method. Whereas enumeration is fail-safe in nature. It doesn't throw any exceptions if a collection is modified while iterating. According to Java API docs, iterator is always preferred over the enumeration. Note: the functionality of enumeration interface is duplicated by the iterator interface. In addition, iterator adds an optional remove operation and has shorter method names. New implementations should consider using iterator in preference to enumeration. In Java 5 introduced concurrent map interface. Concurrent hash map. A highly concurrent, high-performance concurrent map implementation backed by a hash table. This implementation never blocks when performing retrievals and allows the client to select the concurrency level for updates. It is intended as a drop-in replacement for hash table. In addition to implementing concurrent map, it supports all of the legacy methods peculiar to hash table. Each HashMap entry's value is volatile, thereby ensuring fine-grained consistency for contended modifications and subsequent reads. Each read reflects the most recently completed update. Iterators and enumerations are fail-safe, reflecting the state at some point since the creation of iterator/enumeration. This allows for simultaneous reads and modifications at the cost of reduced consistency. They do not throw concurrent modification exception. However, iterators are designed to be used by only one thread at a time, like Hashtable but unlike HashMap. This class does not allow null to be used as a key or value. Null keys and null values. HashMap allows maximum one null key and any number of null values. whereas Hashtable doesn't allow even a single null key and null value. If the key or value null is, then it throws null pointer exception. Example: synchronized, thread safe. Hashtable is internally synchronized. Therefore, it is very much safe to use Hashtable in multi-threaded applications. Whereas HashMap is not internally synchronized. Therefore, it is not safe to use HashMap in multi-threaded applications without external synchronization. You can externally synchronize HashMap using collections.synchronizedMap method. Performance: as Hashtable is internally synchronized, this makes Hashtable slightly slower than the HashMap. @C. A red-black tree is a kind of self-balancing binary search tree. Performance improvement for HashMap in Java 8. For threaded apps, you can often get away with concurrent HashMap. Depends on your performance requirements. 1.HashMap and Hashtable both store key and value. 2.HashMap can store one key as null. Hashtable can't store null. 3.HashMap is not synchronized but Hashtable is synchronized. 4.HashMap can be synchronized with collection.synchronizedMap map. Apart from the differences already mentioned, it should be noted that since Java 8, HashMap dynamically replaces the nodes linked list used in each bucket with tree nodes red-black tree. So that even if high hash collisions exist, the worst case when searching is ON for HashMap vs ON in Hashtable. The aforementioned improvement has not been applied to Hashtable yet, but only to HashMap, linked HashMap, and concurrent HashMap. FYI. Currently, treeify_threshold equals 8. If a bucket contains more than 8 nodes, the linked list is transformed into a balanced tree. Untreeify_threshold equals 6. When a bucket becomes too small due to removal or resizing, the tree is converted back to linked list. There are 5 basic differentiations with Hashtable and HashMaps. Maps allows you to iterate and retrieve keys, values, and both key value pairs as well, where Hashtable don't have all this capability. In Hashtable there is a function contains, which is very confusing to use, because the meaning of contains is slightly deviating. Whether it means contains key or contains value, tough to understand. Same thing in maps, we have contains key and contains value functions, which are very easy to understand. In HashMap you can remove element while iterating safely, whereas it is not possible in Hashtables. Hashtables are by default synchronized, so it can be used with multiple threads easily, whereas HashMaps are not synchronized by default, so can be used with only single thread. But you can still convert HashMap to synchronized by using collections util classes synchronized map m function. Hashtable won't allow null keys or null values, whereas HashMap allows one null key and multiple null values. My small contribution. First and most significant difference between Hashtable and HashMap is that HashMap is not thread safe while Hashtable is a thread safe collection. Second important difference between Hashtable and HashMap is performance. Since HashMap is not synchronized, it performs better than Hashtable. Third difference on Hashtable vs HashMap is that Hashtable is obsolete class and you should be using concurrent HashMap in place of Hashtable in Java. HashMap. It is a class available inside java.util package and it is used to store the element in key and value format. Hashtable. It is a legacy class which is being recognized inside collection framework. Hashtable is a legacy class in the JDK that shouldn't be used anymore. Replace usages of it with concurrent HashMap. If you don't require thread safety, use HashMap, which isn't thread safe, but faster and uses less memory. Hashtable is synchronized whereas HashMap is not. Another difference is that iterator in the HashMap is fail-safe. while the enumerator for the hash table isn't. If you change the map while iterating, you'll know. HashMap permits null values in it, while Hashtable doesn't. HashMap and Hashtable. Some important points about HashMap and Hashtable. Please read below details. 1. Hashtable and HashMap implement the Java.utility map interface. 2. Both HashMap and Hashtable is the hash-based collection and working on hashing. So these are similarity of HashMap and Hashtable. What is the difference between HashMap and Hashtable? 1. First difference is HashMap is not thread safe while Hashtable is thread safe. 2. HashMap is performance-wise better because it is not thread safe, while Hashtable performance-wise is not better because it is thread safe. So multiple thread cannot access Hashtable at the same time. Hashtable. Hashtable is a data structure that retains values of key-value pair. It doesn't allow null for both the keys and the values. You will get a null pointer exception if you add null value. It is synchronized, so it comes with its cost. Only one thread can access Hashtable at a particular time. Example: HashMap. HashMap is like Hashtable, but it also accepts key-value pair. It allows null for both the keys and the values. Its performance is better than Hashtable because it is unsynchronized. Example: HashMap and Hashtable. Both are used to store data in key and value form. Both are using hashing technique to store unique keys. There are many differences between HashMap and Hashtable classes that are given below. HashMap is emulated and therefore usable in GWT client code, whereas Hashtable is not. Old and classic topic. Just want to add this helpful blog that explains this. http://blog.manishjabra.com/2012/08/the-5-5-between-hashmap- Blog by Manish Jabra. The 5 main differences between HashMap and Hashtable. HashMap and Hashtable both implement Java.utility map interface, but there are some differences that Java developers must understand to write more efficient code. As of the Java 2 platform v1.2, Hashtable class was retrofitted to implement the map interface, making it a member of the Java Collections framework. One of the major differences between HashMap and Hashtable is that HashMap is non-synchronized whereas Hashtable is synchronized, which means Hashtable is thread safe and can be shared between multiple threads, but HashMap cannot be shared between multiple threads without proper synchronization. Java 5 introduced concurrent HashMap, which is an alternative of Hashtable and provides better scalability than Hashtable in Java. Synchronized means only one thread can modify a hash table at one point of time. Basically, it means that any thread before performing an update on a hash table will have to acquire a lock on the object, while others will wait for lock to be released. The HashMap class is roughly equivalent to Hashtable, except that it permits nulls. HashMap allows null values as key and value, whereas Hashtable doesn't allow nulls. The third significant difference between HashMap vs Hashtable is that iterator in the HashMap is a fail-fast iterator, while the enumerator for the Hashtable is not, and throw concurrent modification exception if any other thread modifies the map structurally by adding or removing any element except iterator's own remove method. But this is not a guaranteed behavior and will be done by JVM on best effort. This is also an important difference between enumeration and iterator in Java. One more notable difference between Hashtable and HashMap is that because of thread safety and synchronization, Hashtable is much slower than HashMap if used in single-threaded environment. So if you don't need synchronization and HashMap is only used by one thread, it Perform Hashtable in Java. HashMap does not guarantee that the order of the map will remain constant over time. Note that HashMap can be synchronized by map_m equals collections.synchronized HashMap. In summary, there are significant differences between Hashtable and HashMap in Java, e.g. thread safety and speed, and based upon that only. Use Hashtable if you absolutely need thread safety. If you are running Java 5, consider using concurrent HashMap in Java.